Hello, everybody. Thank you for joining me today. This is Faye. I am the Department of Medicine biostatistician. I wanted to go over just some basic methods on how to create your own table one, if you may, that just includes descriptive data and how to go about choosing what type of tests you use to conduct those analysis. So I have a basic data set here that I will use for this demonstration. So let me pull that up. So here is the sample data set. This is a very small data set that has a few variables. We have this intervention variable that's looking at therapies in patients and whether a single therapeutic agent was more likely to help with patient recovery, or whether the combined therapeutic agent that has multiple facets was better. So we have that variable, and in addition, we've collected demographic information such as age and gender. We also have history of the patient, including whether they've had, hypertension, cancer, asthma, whether they've had some transplant, and their racial group. So this is the data set we're going to be using for this demonstration. So now in the beginning, what you want to do is you want to identify what variable is going to be of interest. Usually you're thinking about what variable is going to be your outcome. For this data set, the outcome of the study was mortality. So you can see we have death date here. I will, however, be presenting this in a second part of this video, just so we have the shorter version for a quick descriptive video. So come back to part 2 to learn how to conduct a survival analysis. So to start off, we've looked at the intervention variable. So we will want to start there in terms of our descriptives. You can see that I've titled here categorical variables first. So after you've looked at your data, you want to identify all of your categorical variables. And if you have some group data, you want to start there in terms of that's the group comparison you're going to make. So you can see table 1 here. We've outlined here the single versus the combined therapeutic agent. So what we're going to do is we're going to start there by looking at this intervention. So, in STATA, all you need to do is tab it out. So we can do tab. If you're using other type of statistical software, they will have a different way of writing it up, and I may present some of those in later videos for you so that you can see how to do it in different software. So when we tab this, we see that we can put this information in here right away. We had a total of 49 patients. 25 of them got the single therapeutic agent, and 24 of them got the combined. So you usually want to outline that so that we have the sample sizes to begin with right here. And next, you can go through some of your other variables. So I've just outlined 2 of them, but you can go through all of the other categorical variables in here. So we have all these variables are categorical variables. So you can go through each one of those and include them in this descriptive categorical, and kind of just tab them out and see what percentages they have. We're not going to record that because the main part of this is that we're going to have that show up again for our total column when we go to step 3. So we can do that there. Now in step 2, we just want to look at our continuous variable. So the only continuous variable we have in here is age. And how you look at it is, if you look at age, you can see that it's collected as a numerical variable, whereas all of these other variables are just 0, 1. They may have like up to 5, but age has this continuous nature where the variable has very many levels of different numerical values. So you can look at it as a sum. So you can see here when we did sum age, we get a mean, We get a standard deviation, we get a min, and we get a max. Now, I often get questions like which ones are important to output. For the majority of researchers looking to output data, I would say the min and max is often not that important for your tables. The most important parts are going to be your mean and standard deviation. So again, you can record this. These are the basic descriptors, and I usually go through these steps just to make sure I look up my data beforehand. But the actual recording process starts in step 3. So now in step 3, we're looking at our categorical variables just like we did up here, but instead we're going to be, using 2x2 tables to look at our intervention groups and some other categorical variable. So here we're going to look at gender, and you can see my command is tab 2 because I want a 2x2 table. I also specified here chi2, which is the chi-squared statistical test, and I wanted row percentages. So if we go back to our output here, you can see here on the left-hand side for our intervention groups, we have the combined and the single therapeutic agent. And then on the upper hand, we have the genders. So 0 is if the person is male, 1 is if they're female, and 2 is other, meaning sometimes they didn't answer the question or they just didn't want to identify. So once you have this information, you can now go to your table 1. And in our table 1, we look at a total column for males. So our total column for males is 24. So we can put 24 in here with our percentage, 48. And I like to round sometimes, so I can put 49 in here. We see that under the single, this number is 15, and that's 60%. And then we also see under combined, the number is 9, and that's 37.5%. And then the next thing that you can usually look at here, because you do have the chi statistics that are given to you, but the most important one that we need is the p-value. So the p-value here is 0.01, which is statistically significant. So usually I will bold it, or I will put some type of symbol to show that it's, significant, whatever works for you. You can look at some other, publications to see how other researchers have done it. And then next, we will then go to the second row, which is for females. And for females, we see that the total females is 15, comprising 30.6%. And then we just do the same for each of these. 50%, and then the other we have 10, 20.4, 7, 28.0. So you can see how that comes out, and it's pretty good for your tables. So it depends on what type of journal you're putting your paper into. You may want to switch to column percentages rather than row. And if you switch to column percentages here, you'll see that the numbers stay the same, obviously, but the percentages are going to be presented to you in a column format, rather than the rows that we've had. Next, when we run this variable, which is cancer, you may ask why here I'm using the statistical test called exact rather than chi-square. So the exact Fisher's statistical test is if we have any any observations that have cells less than 5. This is a preferred test. And so you can look here at the cancer. We only had 5 that identified as having cancer. And so because of that, we had columns, cells that had 2 or 3 patients. So we want to just make sure that we're using a robust enough test. And now if you go back to your table, you can record it in here the same way that we did for gender. All right, and then lastly, for your continuous variables, I always run this very first test. So this is an ANOVA test that comes with a Bartlett test that tells you whether your data is normally distributed or not. When we run this statistical test, you can see that it gives us the sum of squares, but it also gives us this p-value here. And usually people don't know whether they need to use a t-test or whether they need to use some type of non-parametric test. You know, and a one-way ANOVA is a good way to see that in statistical decision making and, you know, decide then whether you want to use a t-test. So when you look at the Bartlett test, what you're looking for is if this p-value is statistically significant, then that means your data is not normally distributed. And because of that, you would have to seek another test rather than a t-test to run your comparisons. Seeing that this value isn't statistically significant, we're going to go ahead and run a t-test for this. And when we run a t-test for this, you can see the p-value came up the same. So the first one we ran, it was 0.199, and the t-test is still 0.199, but it tells us that you're using the appropriate test. And so once you have that, you can then go back to your table. We want to kind of record our combined age here, which is 54.5. And then you can choose whether you want to report a standard error or standard deviation. Again, most journals prefer standard deviation unless they tell you differently. I usually will use standard deviation. There are other ways where, you know, if your data wasn't normally distributed, as I had shown before, then you would have to use, you know, median and IQR. And I'll discuss that in future lessons. And then when we go to our single therapeutic group, this is 56.2 with a standard deviation of 8.4. And then our combined therapy group, 52.8 with a standard deviation of 9.7. And then you can put the p-value here. Again, I usually will round up. So I put 0.20, and it's not statistically significant, so I leave that unbolded. So this is how you go through the basic processes of creating your table 1. That includes descriptive data, your raw data, as well as percentages and continuous data summary. I will go ahead and talk about how to run regression models specifically for this data. We will be conducting a survival analysis, and I will do it in part 2.